Namaskar, welcome to Exercise Explained. In this video, I will be doing question number 15 and question number 16 of exercise 5B Upthrust in Fluids, Archimedes Principle and Floatation, ICSE 9th Physics. The previous questions have been done in the previous videos, the link for which will be there in the description below. If you like the video, do share it with your friends and consider subscribing to the channel. Starting with the 15th question, a piece of iron weighs 44.5 gram force in air. So weight in air is given as 44.5 gram force. If the density of iron, so here the density of iron is given as 8.9 into 10 to the power of 3 kg per meter cube. We need to find the weight of iron piece when it is immersed in water. So it's a simple problem. We would be finding the relative density first, and then by using another formula for relative density, we would be getting the weight in water. So we would be writing the given data. So weight in air, that would be WA, will be equal to 44.5 gram force. So when we convert gram force to newtons, we divide by 100 and we get this as 0.445 newtons. Weight in water we need to find. We need to find this. Density of iron is given as 8.9 into 10 to the power of 3 kg per meter cube. Density of water, we should know it as 1000 kg per meter cube or 10 to the power of 3 kg per meter cube. Now I would be finding the relative density. So relative density will be equal to density of iron divided by density of water. So density of iron is 8.9 into 10 to the power of 3 divided by density of water happens to be 10 to the power of 3. 10 to the power of 3 and 10 to the power of 3 cancels. So we get the relative density as 8.9. Now that we have got the value of relative density, we will use another formula for relative density, which happens to be RD is equal to weight in air divided by weight in air minus weight in water. So weight in air, we know it as 0.445 divided by weight in air is 0.445 minus weight in water we need to find. So now I would substitute relative density as 8.9. So 8.9 is equal to 0.445 divided by, we get this as 0.445 minus weight in water. So this will go to the left hand side and we get 8.9 into 0.445 minus weight in water is equal to 0.445. Now I would take this 8.9 to the other side. So we get this as 0.445 minus weight in water is equal to 0.445 divided by 8.9. Now we would multiply numerator and denominator by 1000 so that the decimal is not there. So we get this as 0.445 minus weight in water is equal to 0.445 into 1000 will be 445 divided by 8.9 into 1000. I would write that as 89 into 100. I would tell you the reason why. Because 445 divided by 89 straight away gives me 5 times. So I can cancel this 5 times. So we get this as 5 divided by 100, which is nothing but 0.05. So we have got 0.445 minus WW, that is weight in water, is equal to 0.05. Now we would take weight in water to the other side and 0.05 to the other side. So we get 0.445 minus 0.05 is equal to weight in water. So 0.445 minus 0.05 gives us, so here it will give us 0.395. So weight in water happens to be 0.395, and since we are doing it in newtons, it's going to be in newtons definitely, and the textbook answer is given in gram force. In order to convert this to gram force, we can multiply by 100. So 0.395 into 100, so that would give me 39.5 gram force. We can definitely leave our answer at 0.395 newtons because it is not specified in the question to convert it into gram force. So getting to the next question, that is the 16th question. So for the 16th question, it's a pretty long question actually. A piece of stone of mass 15.1 grams. So mass is given as 15.1 grams. I would underline that. Is first immersed in liquid. It weighs, so in liquid it weighs 10.9 gf. So weight in liquid is 10.9 gf. And then it is immersed in water. It weighs 9.7 gf. So I would write the given data first of all. So weight in, the mass is 15.1 grams. So when we convert grams to kilograms, we divide by 1000. So we can write this as 15.1 into 10 to the power of minus 3 kg. So that would be our mass. Weight in liquid, so WL will be 10.9 gram force. So again we need to convert this gram force to newtons. So we divide by 100. So we get this as 0.109 newtons. So weight in liquid is 0.109 newtons. Weight in water, so that is WW, will be equal to 9.7 gf. So I can write that like dividing by 100, we get this as 0.097 newtons. So we have got weight in water as 0.097 newtons. Now we would be finding the weight in air because we know the mass. So weight in air will be equal to m into g. I would consider g to be 10. So m is 15.1 into 10 to the power of minus 3 into 10. So 10 is going to be 10 to the power of 1. So we can write that as 15.1 into 10 to the power of minus 2, because minus 3 plus 1 gives us minus 2, or we can write it as 0.097 0.151, and this will be in newtons. So we have got most of it. Weight of the body in liquid is 0.109 newtons. Weight of the body in water is 0.097 newtons. Weight of the body in air, so that was the first part of the question, that we got it as 0.151 newtons. Now upthrust is always going to be weight of the body in air minus weight of the body in water. So here I would write upthrust is equal to weight of the body in air minus weight of the body in water. So weight of the body in air happens to be 0.151 minus 0.097. So 0.151 minus 0.097 gives us 0.054. So we get this as 0.054, and this would be in newtons because it is upthrust. So now we know another formula for upthrust, that is upthrust is equal to V rho g. So I would be using that. Upthrust is equal to V into rho. Here it will be density of water, please remember, into acceleration due to gravity, because it is being immersed in water. So here I would be finding the value of volume from here. So volume is going to be equal to upthrust, that is 0.054 divided by density of water, and acceleration due to gravity goes to the other side. So density of water is 10 to the power of 3 into acceleration due to gravity is 10, which can be written as 10 to the power of 1. So we get this as 0.054 into 10 to the power of 3 into 10 to the power of 1 gives us 10 to the power of 4, and 10 to the power of 4 goes to the numerator, becomes 10 to the power of minus 4. So we have got it as 0.054 into 10 to the power of minus 4, and since this is volume, it's going to be in meter cube. So that would be our volume. We can actually multiply and divide by 100. So when we multiply and divide by 100, we get this as 0.054 into 100 divided by 100 into 10 to the power of minus 4. Now 0.054 into 100 gives us 5.4, and divided by 100 goes to the numerator, becomes 10 to the power of minus 2. So 10 to the power of minus 4 into 10 to the power of minus 2 gives us 10 to the power of minus 6 meter cube, which can be written as, if we have to convert it to centimeter cube in order to get the textbook answer, 5.4 into 10 to the power of minus 6 into 10 to the power of plus 6 centimeter cube. Whenever we are converting meter cube to centimeter cube, we multiply by 10 to the power of plus 6. So we get this as 5.4 centimeter cube. So that would be our answer for volume. So we have got the volume as 5.4 centimeter cube. Upthrust, the answer given is 15.1 gram force. Not upthrust, it is the weight in air is given as 15.1 gram force. We have got it as 0.151 newtons. So when we convert 0.151 newtons to gram force, we multiply by 100. So that gives us 15.1 gram force, and that would be our textbook answer. So we have got two things till now. We have got the volume of the stone and we have got weight of piece of stone in air. This sum is slightly long actually. So here the next thing which we need to find is relative density. So for finding relative density of the liquid, relative density of the stone we need to find first. So for finding the relative density of the stone, I would write here Rd of stone. So Rd of stone, so that would be our third part actually. So that would be weight in air, the same formula, weight in air divided by weight in air minus weight in water. Weight in air is equal to 0.151. So 0.151 divided by 0.151 minus weight in water is given as 0.097. So that would be 0.151 divided by 0.151 minus 0.097 gives us 0.054. So 0.151 divided by 0.054 gives us 2.79. So here we get this as 2.79. So the relative density of stone is 2.79, which is approximated in the textbook as 2.8. So that gives us the C part answer. So we have got the C part. Now we need to find the relative density of liquid. So for finding relative density of liquid, I would write Rd of liquid. So that would be equal to weight in air minus weight in liquid divided by weight in air minus weight in water. So we just substitute the values. Weight in air is 0.151 minus weight in liquid, it's given above as 0.109 divided by weight in air is again 0.151 minus 0.097. So 0.151 minus 0.109 gives us 0.042. So we get this as 0.042 divided by 0.054. So we multiply numerator and denominator by 1000 so that the decimal is not there. So we get this as 42 divided by 54. So 42 divided by 54 gives us approximately 0.78. So 0.78, and that would be the relative density of the liquid. So we have got all four parts of it. So this completes exercise 5B. It was a very long exercise. Hope you guys like the video. Do share it with your friends and consider subscribing to the channel. Dhanyavad.